So guys, thanks for joining us.
Great to
Thanks,
be here.
great to be here.
Looking forward to the chat.
Same here.
Same here.
So I just want to go around the horn and have each of you introduce yourself briefly and just explain what the business does and what your role is in the company, if you don't mind. Soheil, please.
For sure. So hopefully everyone's heard of Anthropic. We are an AI foundation model lab focused particularly on safety as well as building frontier AI models. And I'm on the product research team. So when you think about AI, there's like the pre-training, post-training. This is part of post-training. And we're trying to find ways to make our models useful for developers, for products, and sort of the work that I focus on. And prior to Anthropic, I was working on self-driving, which is another very difficult AI problem, focused particularly on vision and perception.
Hi, everyone. It's great to meet you all. I'm the CTO of Pinecone. For those of you who don't know what Pinecone is, we are a vector database company. So if you're doing semantic search, or if you're doing RAG and so on, chances are you're either using us or know about vector databases and so on. I lead all aspects of engineering and research at Pinecone. Prior to Pinecone, I was at companies like Databricks, Yahoo, and so on. I have an interest and passion for data and systems. So machine learning and systems and fun systemic challenges in the intersection of those two.
Hi, everyone. So I work together with this amazing group of people together. And our mission is really try to build a cloud platform for generative AI, how to make that cheaper, how to make that faster, how to make sure that's really easy to use, that everyone do not need to worry about essentially like really deep on the technical side, but can focus on building what's really amazing, right? So yeah, before together, I was a professor at ETH Zurich for 7 years. We have been working on machine learning systems this whole time. Yeah, really exciting to see many of them kind of seem to the right time to bring them to the real world. Yeah.
Amazing, thank you. So I want to kick it off thinking sort of about where we're at today in the development of the modern AI stack. I think most of us probably agree or intuit that the stack will be different than the old machine learning stack that we're used to. I think tools like Pinecone and others are proof or manifestation of that. I guess the question I wanted to ask is, in spite of that fact, what is it that we learned from ML ops, say, in the last 10 years or so, that sort of informs the way you guys think about how developers should be thinking about building on the new AI stack? Like, what are the similarities? What are the differences? Like, what are some of the new mental paradigms that we should be looking at, or how do we compare and contrast the two?
I mean, one thing I can start with, I was working on AI for vision and for self-driving. And that's a pretty safety-critical use case. And one thing that's been the same when working on ML is being able to understand and evaluate your models and to understand how well they're doing. And that's becoming even more important as these models kind of take actions that are in a pretty large scope and in a large space of possible things that they can do. So like that's still the same. You need to evaluate and also monitor how they're doing. I think in particular, like before, again, because they were scoped in terms of the types of actions they can take, once they were out, there were maybe some specific metrics that you track and then you're done. Now you need to be a lot more diligent with how you monitor your models, how you get feedback from your customers, and make sure that that loop is like very tight and there's always a human involved. So those parts I think are the same.
Yeah, I think some parts that are still the same are, as Soheil touched upon, it's the training data. If you're doing fine-tuning, you have to worry about the size of your data sets, the quality of your data sets, bias in your training data, and things like that. So that stuff is still the same whether you're doing ML ops or AI ops and so on. I think what has changed quite a bit is that most people don't even have to tune models or do anything today to actually get value out of generative AI, right? So it has changed in some sense the things you worry about. For example, now you worry about groundedness. You worry about, is your model giving you factually correct answers? You worry about, is it correct? Is it hallucinating? Is it giving you correct answers and so on? So there you worry more about these new types of metrics and new types of evaluations that you weren't probably thinking about before, right? Before you were tuning it or training it for some very specific tasks. And if you could basically quantify its performance on that task, you are mostly done outside of looking at things like drift, right? What happens if your test distribution changes and drifts and so on. But now because you're not the ones who are training these models, and these models have massive capabilities that are transfer learning on tasks with few shot prompting and so on, you suddenly have to worry about what they know, how they use what they know versus what you want them to do, right? So I think in those aspects, it's somewhat very different. AI ops is quite different in that aspect.
Yeah, totally agree, right? So I think the capacity of the model going to make evaluation much, much harder, right? So I think it's going to be baked into the whole decision-making process of every single application, right? So I think they're going to be kind of very different. So I guess if there's one similarity we draw from ML ops to AI ops that are kind of similar, so I think is, so before ML ops, right, so machine learning application was built in a pretty monolithic way, right? It's a kind of a big piece of code, all the processes just like smashed together into a single thing, right? So I think we are actually here pretty much for generative models, right? So there's no essentially kind of design pattern about different processes, different guardrails, different kind of steps for you to actually bring an application into production, right? So I think one thing that's amazing that ML Ops has been doing is really try to model what are different pieces that we need for building an application. I think that they will count for AI Ops, right? It's going to be a very different process, but I think that systematic process will probably be there. The whole thing become very, very modular, right? So, and then people can innovate within the scope of each module, and then we have this like common pipeline, which is kind of this AI ops pipeline, kind of stick everything together, right? So I think that will come, right? But need the whole community to figure out what that thing actually is.
Well, say I wanted to ask you about that because, and forgive my ignorance, but from the outside, I would suggest that Together looks a little bit, your company Together looks a little bit like a vertically integrated sort of model application development stack. Is that fair? And if so, are you trying to support deployed applications with some of the monitoring and some of the other guardrails and testing and other things as part of your platform? Or is that not exactly the vision of Together? If you could clarify, I'd love that.
Yeah, so I think we want to be this platform that everyone kind of begin with, right? So when they want to do generative model, they begin with that. And also we want to be the platform that people stay, right? Support them all the way at all the different stages of the process, right? So, and to do that, we need the inference, we do fine-tuning, right? So I think we also need monitoring all the things, right? But I think what's really important for building a platform is not really whether we can build everything. It's really what is the right abstraction to make sure we can use help from everyone, right? So I think what's probably this is the professor side of me speaking. So I think we'd rather have the ecosystem look more like Linux, that every single small pieces kind of stick together and people can innovate within this very small tool, and then you have this like vertically integrated like system instead of having everything like smashed together and no one can innovate at every single component. Yeah, I think the former one is probably a better alternative for everyone. I think for us, also for the community, and also for the ecosystem as a whole. Yeah.
Well, let's linger on the AI ops piece for a bit, because I'm glad that each of you mentioned evaluation and monitoring. These are both incredibly important things for newfangled LLM-based apps. And as I sort of scour companies in the community, as folks have submitted to speak at Data Council, there's a lot of activity in startups in both of those spaces. I'm curious, let's zoom out from the tool lens for a second and just talk about sort of the basics of what engineers or developers face and the challenges they face. Like evaluating your non-deterministic LLM models is so completely different than any kind of ML testing, testing or evaluation that we've done before. Where do you see developers typically get tripped up in this area?
I think there is the ability to like iterate on your prompting strategy, which I think is one set of tooling that is like very helpful and beneficial. And then there is, okay, you have your model's outputs and now you're trying to evaluate its performance in production. I think like you have to start by identifying the scope of what you want your model to be able to do, and make sure that, first of all, you don't have too big of a scope and that it's narrowed and it's something that can be immediately measured in terms of its ROI, because knowing exactly what you want it to do can be very helpful figuring out how you're going to measure that. So without that, I think people trip because they are coming up with, they have too big of a scope, and it's hard to come up with metrics that actually measure what you want it to do. So that's the first thing I would say, is to like focus on identifying exactly what you need to do. And then the other I would say is like try to use models to assist you in that process where they can be helpful. Like often you can use a model to grade the output of an existing model. And again, as long as you have humans in the loop to make sure that things are not like diverging off distribution from what you're looking for, that can be immensely helpful in at least growing the size of the data that you're evaluating on. But those are like some of the things that I think are important in that area and things to like watch out for.
Yeah, I think there's two issues here, right? One is the fact that the models themselves are probabilistic, which, by the way, was the case with ML models in general. But I think we are getting more used to the probabilistic nature because it's more widespread in use, and it has a lot of value, right? So there is that aspect of it. But there is also even if you look at LLM leaderboards, or even if you look at embedding model leaderboards and so on, most of these models are trained on pretty much the same data, right? And it's hard for you to actually quantify whether adding some steps to the pipeline or doing something with them is actually really improving things, right? Because it's improving stuff on things that the model already knows about. And that improvement may not translate to out-of-domain data sets, out-of-domain tasks, and stuff like that. So when I'm thinking about metrics and evaluations and stuff like that, it's really important for you to ground that in your own data, to ground that in your domain and the things that matter to you, because often you will find that results might vary quite a bit based on what the model has been actually trained on, right? The other thing is that most people, there's a lot of choices right now between pre-training, fine-tuning, prompting. I would say always start simple. The prompting is probably the simplest thing to do. It's easy, it's more specific, so you can do this for your own task, and it's cheaper for you to do it, economically better, and also faster for you to know whether something is working or not. And from there, you can go stepwise to fine-tuning and pre-training as your case may be. But first, get the evaluation metrics and the data sets correct, and probably fine-tune to your own task. So to me, it's more about actually making sure you have the right data and the right labels and human in the loop in actually evaluating this. Because even if you use larger models to evaluate smaller models and stuff like that, if they're all trained on the same data, it doesn't really matter that much.
Well, let's talk about the RAG component for a bit, because this is, it seems to me to be sort of the front door that most developers go through. Obviously, fine-tuning is its own set of challenges, and I hope to touch on that with you all as well. But why don't we start with the RAG side first? So, Ram, you're sort of the local expert on this because there's a whole new piece of infrastructure designed to support nearest neighbor and vector-based searches. So talk to us a little bit about how you saw that unfold at Pinecone, and what's the minimum viable sort of familiarity that engineers in this room need to have with this technology to use it?
Yeah, so maybe before I start with vector databases and so on, let me just explain what RAG is, right? So LLMs, first of all, have been really powerful because, like I said, you don't really need to train them these days. You can just start with even zero-shot learning or few-shot learning through prompting. So you don't need to be a machine learning expert to actually get a lot of value out of language models. These language models are extremely powerful because they've been trained on huge corpora of data, and they embed world knowledge in their parameters, right? That's massive. But they hallucinate, they don't have access to your private data. Even if you somehow were to give them private data, they don't really know what to use, what not to use, and so on. So there's a lot of complexity hidden in the structure of language models. So RAG is an attempt to actually ground them in real data. So in other words, what these language models are really good at is reasoning, and tool use, and so on. What they aren't necessarily great at today is access to relevant, accurate knowledge. So this is a problem that people have known roughly how to solve for a long time, and that goes under the umbrella of information retrieval. So a few years back, there was this paper on retrieval augmented generation, or what's called RAG, which suggested that, hey, a way to actually solve this problem with LLMs is to have LLMs have access to information retrieval. Okay, so let's take your corpus, put it into something that can actually retrieve data for you, and this retrieval has to be such that I give you a query, and you give me the semantically relevant portions of your document, and I'm going to take that and feed it to the model itself through prompting for the model to actually make use of it and give me an answer, right? So the model is now a question answering system that has access to this extra context that's coming from semantic search on this sort of a corpus, right? And the way to do semantic search on this sort of a corpus is through what's called a vector database. The idea is that you take pieces of text, you embed them using an embedding model, and you put those embeddings, which you think of as an array of floats, into a database. This database is now efficient for queries, where you can think of a query after embedding as a point in some space, and you look at the nearest points in that space to the query, and ask for the top 10 of those points or top 100 of those points. That's supposed to tell you something about the semantic similarity between the query and the content or the document, right? That's the general idea, and once you have that piece of infrastructure, now you can connect that with an LLM and put this extra documents or extra passages into that context. That's the whole idea. Now, the reason why it works, of course, is that it uses information retrieval to fetch relevant, accurate knowledge. So the language model doesn't have to hallucinate or figure out how to get that knowledge, and is able to do in-context learning because language models have evolved to do in-context learning. That's the whole idea, okay? But this is really like step 0 of what RAG is, because this is what's called frozen RAG. It's frozen RAG because the language model is frozen. It's been trained and you're no longer fine-tuning it or doing anything to it. It's frozen information retrieval because you're putting some stuff, embeddings into a database, you're searching for it, you're not changing the embeddings, you're not changing the queries, you're not doing anything with it. You're just connecting the two systems together. It turns out that even that is actually pretty powerful. So even that allows people to make a lot more progress than they could make before. But when people use RAG in the community, in literature, for example, they really mean a RAG that's actually end-to-end fine-tuned. So you can actually now think of this thing, and instead of freezing both the language models and the retrieval, you can fine-tune retrieval, you can fine-tune language models, you can fine-tune both. And that gets into all the varieties of what's called retrieval augmented generation.
And so the future applications, they'll be greatly affected by context window size changing, and we're seeing context windows expand all the time.
Yeah.
What's the panel's thoughts on how this sort of affects this RAG pattern in the future?
Well, so I think context window will always be limited to some degree, in the sense that the more you stuff into the context, the slower your response is going to be from the language model. And your standard attention mechanism is like quadratic in its like complexity relative to the number of tokens in the window. So I think that context windows will get bigger, and that will mean that you actually can more often throw everything into the context if the latency requirements that are met for your application, which will reduce the need to jump to RAG right away to basically get smart about what you fit in there. But then that means we're going to have the ability to use more and more data sets. So the bulk of data that you're going to want to try to fit in is also going to grow. And so you'll always need some tool to allow you to figure out which parts are most relevant. And I think you can think of it like a bit like a computer, right? You have RAM, and it's limited, but it's really fast. And RAM is like the context window for an LLM. And you can't put everything into RAM. You have to be mindful and smart about what you're going to put in there to get like the highest, the working memory of the model. What you're going to put in there. And so I think we're just going to get a lot smarter about how we do that. Like right now, it looks like vector search and similarity search, and then just throw those snippets into the context. But in the future, models are going to be involved in that process. It's going to potentially involve synthesizing information or multiple steps. And so I think it'll look similar, but more intelligent.
Yeah, I think there's really two aspects to the context window. First is, I think as you mentioned, Soheil, the size of the context window means that your language model is doing quadratically more work, which is actually pretty inefficient, right? If you put all of Harry Potter inside the context, that's a lot of data to munch through and actually suss out for you to answer some very simple question about one of the Harry Potter books. That's one aspect of it. But the other aspect of it is also this needle in a haystack problem, which is, okay, now we have the whole book or a whole corpus or whatever it is, and you have this problem of figuring out what parts of this are actually relevant, what parts are not relevant, right? Again, without fine-tuning, without pre-training and so on, it's much harder for a language model to do this in context. And this has already been shown. It's already been shown that the language models actually preferentially look at early parts of the context window or late parts of the context window better than they can look at the center of the context window. Okay, so there's no free lunch here. Okay, so even outside of the computational complexity, it's not necessarily very efficient. Now it does become more efficient, and the context window does become useful. Having a larger context window does become useful if you feed it the right context. Right? If you feed it the right context, you can now feed more context, and you're not feeding it information that it has to figure out how to discard. That's the key. So I don't think context windows actually replace RAG or retrieval or any of these things, but they complement it. In fact, one thing that is different with large context windows is, prior to large context windows, you would see that anyone working in information retrieval would be spending a lot of effort thinking about how do I retrieve, then re-rank, how do I make sure that the re-ranked results are small enough so that I'm computationally efficient, all of this stuff. Now you don't need to think that hard. As long as the retrieval is good enough, as long as the re-ranking is good enough, you can actually re-rank and fetch more results. Let the LLM do the final aggregation, do the final summarization, or extract the relevant pieces of information it wants, because you're giving it relevant context. You don't need to worry about giving it too much relevant context. So in some sense, large context with windows are useful, but it doesn't replace RAG or replace kind of retrieval and so on.
Yeah, so definitely agree with like all the points. So I think interesting to imagine what would happen, for example, fast forward in 5 years, right? How do we even think about context window as a concept, right? So I think that when we talk about context window, I think today we are talking about pretty much multiple things kind of smashed together, right? So first one, there's the context window as a upper limit, right? If you gave, for example, like a mixture of like 60K tokens, it will break, right? So there's this like very hard limit that we are associated with context window, and then there's this like quality perspective, and then there's this efficiency perspective, right? So personally, I feel context window as a limit will probably go away in the next couple of years, right? You can probably push a whole bunch of things, right? The whole thing won't break, right? So I think that will come. So I think the quality part, somehow I'm a little bit optimistic that will probably go away. Yeah. So like the artifact that you mentioned about, it's kind of good at the beginning and the end, very bad at the middle. I think that's more like an artifact about how we build those models instead of anything fundamental. So I think efficiency will be a very, very big thing, right? So part of me think about RAG and attention. It's pretty much RAG is just an efficient way for you to handle attention, right? In essentially constant amount of time, right? So attention do the same thing, right? You have all the tokens, right? You can compute the similarity and you just public information. I mean, it's not that different from just like search the most important one and hit the top K, right? It's like a more sparse version of attention at a kind of different granularity, right? Yeah. So somehow I feel maybe in 5 years when we talk about context window, maybe RAG will become native in the architecture design. I think that could be cool, right? So I think that could give you a very interesting architecture. Maybe RAG will just be there as a first step of doing information. Maybe we just learn the whole RAG process end to end. That could be an interesting architecture to build. Right?
Yeah, 100%. I think you're right that RAG in some sense will become fused into the language model itself. I think my point was simply that you have to anyway make the context windows attention span sparse. And when you do that, you're basically doing RAG. Whether RAG is now happening externally or internally is a matter of where it sits.
Oh, exactly. Yeah, so I think RAG is a very powerful booster of the context window, right? Because it kind of bake in this like sparsity of context, yeah, and can be supported in a very, very efficient way, right? In Pinecone, and the whole thing is super, super fast, yeah, right? So I think kind of, probably both will stay and start to merge. Hopefully you'll have this like differentiable end-to-end RAG and model architecture, I think that would be extremely cool.
Yeah, in fact, one of the RAG architectures, Realm or Raft, or many of these are actually differentiable end-to-end architectures. Exactly. Great point.
So I like this sort of notion of helping the model focus its attention on sort of what you're interested in, because obviously these models are so large. As you're moving in this continuum from RAG to fine-tuning, I'm wondering, like, what's the mental model that engineers should understand or embrace in terms of, like, when do the benefits of RAG end and the benefits of fine-tuning begin? Like, we're all going to start likely on this RAG paradigm, but what triggers an engineer to know that it's time to you've pushed RAG to the limit and it's time to start to think about real fine-tuning use cases?
Yeah, I would say RAG is more focused on bringing relevant data into the context of the model. And I'd say fine-tuning is more about directing its behavior to match what you want it to do. And there's ways to do that without fine-tuning, right? You can provide examples in the prompt. You can ask it to behave in a certain way, and you give it examples, and it can do that. And sometimes that is sufficient, and I think that's where all developers should start, and that's, I think, where they all start today. Then at some point, you maybe have a large enough data set that actually fine-tuning can help you get a little bit of an extra boost. And I think you start with prompting and then potentially consider fine-tuning. And I think fine-tuning also works with RAG. And most of the time you want to have, because they kind of focus on different things, you'll often have, when you're doing your fine-tuning, you'll have RAG as a part of it. The fine-tuning examples will be like, okay, take this action or answer this question. Here's the context that I've pulled up with RAG. This is and then you teach it to answer based on that context and the prompt. And now you're doing, at the end, a fine-tuned model with RAG that's able to normally outperform just RAG or just fine-tuning or just few-shot prompting.
And when it comes to building more complicated LLM-based apps, I'm also curious your thoughts on performance, because there's a lot of performance implications obviously it's a new architecture, and so there's things to be worked out. Obviously the cost of inference and the speed of inference will drop. There's cool tech like Grok, which is super, super snappy and super quick to get your responses back from the model, right? So there's quantization, there's optimization, there's other things, and I'm sure Say would have a lot to say about many of those deeply technical improvements. But aside from those, what are sort of the application architecture improvements that we should be thinking about in terms of making sure that we're putting ourselves on a solid foundation to build performant applications?
Yeah, I think generally you want to start with the best models first and just make sure your applications work. Once you've established correctness, grounding, and all those things. I do think that language models, especially the proprietary ones, are expensive but very powerful. You may not need all that power all the time. So in some cases you absolutely do. In some cases open source language models might be good enough. Going back to vector databases, in some cases you can use quantized vectors and you can actually get just fetch more from the database and you are good enough. Sometimes you actually need that position. So I think it's very much an experiment and see what works best. I think for that, again, as long as you have good evaluation metrics and you understand what you're measuring, there are ways to actually tune these pipelines. So right now, I would say that the defaults will be fairly expensive, right? But depending on your use case, you may not need the best language model out there. In fact, we've shown that you could take GPT-3 and put world knowledge in a vector database and get GPT-4-like performance, right? 3.5-like performance. So you don't really always need the most up-to-date language models. You could use open source language models. You could quantize vectors. You could just fetch more vectors and put more stuff into the context and so on. So a lot of ways you can play around with this, but it's still a little bit more of an art than a science at this point.
Got it. We want to leave some time for questions. So if folks in the audience want to prepare questions for the panelists, please start. And Scott will be running around with a mic. Thank you, Scott. So as we think about this open source, first of all, there's the open source versus closed source argument. And there's lots of open source junkies in this room. Contributors, users, we're all users of open source. Many of us are contributors as well. So let's assume that there's sort of a meaningful place for open source models in the future, which I think we all agree there will be. How should engineers be thinking about which base models to use for which use cases? Is there anything clear yet in terms of sort of the competitive layout of the way these open source models are being oriented for particular use cases?
It isn't 100% clear yet. It's just very much an art. By the way, Databricks just released an open source language model just today. I just saw it in my feed. So I think they're claiming to be better than Mistral. So I think the pace at which even open source models are developing is rapid. So anything I say today will probably be false in a few months, right? So that said, I would say that it's becoming relatively clear that if you're thinking about embedding models and if you're thinking about re-rankers and these sort of things, you don't need to use proprietary models. That part is becoming clear. What's not clear is actually the LLMs themselves, which is if you're really using language models for reasoning, then I think there is still a material difference between proprietary large language models and open source models. Maybe not on all tasks, but certainly on a good number of them. So this part is still very unclear. So it's very much an art. You have to just test it out and see what works, what doesn't work.
Yeah. So I think like one power of the open source model is essentially the diversity of the model, right? Instead of having a few the really good model, you have this huge collection of models. It's a big world, right? So at some point, someone have a similar like type of data as the thing that you care about, right? You start to have this like ecosystem, just like build up like with a whole bunch of models with different type of expertise, right? So yeah, so definitely agree with you, right? So I think, just try, right? And sometimes you'll be positively surprised about, I mean, there's some model kind of much smaller than a big closed model, but happen to fit your application way better and way cheaper, right? I think diversity will give you, kind of more cost optimization that can potentially do, right? Yeah.
So across this emerging infrastructure stack to make LLM apps operate at internet scale, what do you think the big gaps are in terms of where should engineers or startup founders be thinking about contributing to the conversation, through code, through companies? Like, where are the gaps in the infra world, do you think? And what should folks in this room be thinking, like, in terms of holes that they can fill potentially?
So I think one thing to be wary of is making the assumption that these foundation models are not going to improve in significant ways, and the goal of the startup in one form or another is to kind of fill the gaps in its capabilities today. I think that's probably not the right approach to take as a startup. I think you want to be assuming that these models are going to get better and better every single year, and given that assumption, figure out what is going to stand the test of time and still be useful as their capabilities improve. And I think there's a lot of potential there, and I think obviously in the AI infrastructure stack, but also in the AI product and development stack, building a product that will get better when GPT-5, when Anthropic's Claude 4 comes out, your product will get even better. That's the kind of startup you want to think about.
I think immediately about guardrails and security, right? And I think about this, that there's a potential to build a shell, a safety rails around the LLM as a third-party company. But with these use cases or these implementations, it will also be possible to put the stuff in the model itself. Any clear ideas on whether founders should steer towards or away from those particular ideas?
I think more and more, like the LLM architecture will evolve, and the vector database architecture will evolve to a point where this problem will kind of be foundationally solved. Okay, so guardrails I think are super important. Correctness and things like this are super important. Security is super important, but I think it'll be solved in a foundational way. So unless you are willing to be part of that foundational journey and that the startup was really foundationally trying to disrupt it, which means disrupting the whole ecosystem that way, I wouldn't encourage anyone to kind of go down that path. But there is other paths, for example, I think what you brought up, which is building applications that will get better as the foundational models get better, as the foundational RAG architectures get more fused into this in a more holistically better. I think that's worth doing. The other thing is just data sets. Like just, there is a lack of data sets in this ecosystem. So we are all basically training on the same data. And there's only so much you can do with that. So focusing on how to actually get data, label data, like use human feedback, especially in these domains where it's hard to get data, right? And data is the key to building better models. So
we had such a powerful example of that this morning in the keynote with Joey Gonzalez and talking about the power of unique, clean, high quality data. And it's amazing to me how after all these years, data is still king. And we weren't wrong about data quality, and we weren't wrong about search, and we weren't wrong about labeling, all these things. Because as you start to want to build fine-tuning pipelines, all these things come back to bear again. And so it's critical that enterprises have their data house in order if they want to do meaningful RAG or meaningful retrieval or meaningful fine-tuning. So it's quite remarkable, and I think the folks in this room have had a front row seat in understanding that and building many of these systems over the years. So kudos to all of you who are working on these problems. So I want to take a couple questions since we only have a few minutes left. Do we have a mic? We have one in the front here. Oh, and Misty has one.
Hello. So a lot of us are sitting on a massive treasure trove of like tabular data that we've collected over years. What can we do to leverage that? Because all the LLMs, are working on unstructured data. So what can we do with all this moat that we've collected that's not obviously operable or usable?
That's a great question. So it depends on what you want to do with tabular data. So by the way, I think with tabular data, there are people working on being able to extract tabular data and use it with language models for aggregative queries and so on. It's still very early. I think there's still a lot that needs to be done for language models to be able to do this well. I think if you have tabular data, but you're today, you just want to augment that post-retrieval and post this sort of getting factual knowledge, there are ways to do that. You don't need an LLM to do that. Like you can use the language model to act as an agent, get you the data that you need. Then you can augment it with your tabular data, which you still have tabular databases that do that pretty well. My suggestion would be to start there. But also, in some cases, you may actually be able to prompt language models to do some things here. They're very limited in what they can do in terms of aggregating information right now.
Yeah, so I think there's multiple things that's kind of very cool, right? If you think about relational database, it's essentially where all the knowledge is, right? So that's why that thing exists, to really store all the knowledge. It's definitely a very natural case for you to do essentially RAG, right? So you can have all your SQL queries, right? Have this language model as this language layer to communicate with the user. But I think another cool thing is, so at least myself is kind of surprised how powerful language model is to solve many of the traditional relational database problems. Data cleaning, data integration, right? So many of the problems you are actually having today in your relational database, maybe try a language model to see if that can help, right? So kind of the other way around,
I also think increasingly you'll be able to give language models the ability to access your tabular data as a tool. So you can write SQL queries for you. You can ask it to act like an analyst and pull up the data that's necessary. And I think that's a really powerful, useful use case for having a model not directly embed that tabular data in its context, but be able to interact with it in the way that a person would.
Someone else.
Thanks again, team, for the great panel. Quick question on my end. What are your thoughts on, over time, within any kind of problem set, a mixture of models starting to be used, so that you may actually have one task, but that task includes using different model providers, faster, slower models, verticalized models, et cetera. You think that's going to start to pick up as teams start to realize, there's actually a lot of models around and there's different things they're great at. How do I mix them all and extract the best aspects?
So sort of a model federation kind of a use case,
Yeah.
Absolutely.
I think absolutely. And it also goes into the economics itself. Like we talked about, some models are just expensive. Sometimes you need to do that expensive thing. Most of the times you don't. So there's going to be that ecosystem that actually allows you to orchestrate this. Right now, everybody is doing it themselves, but there will be that ecosystem.
Yeah, I think the idea of like composing lower intelligence, higher intelligence, lower context, higher context models will be like, is like really useful and like enables all kinds of use cases that would be prohibitively expensive if you just had access to the most like high-end expensive model. Like right now, like Anthropic's Haiku model, which is like our fastest model, is almost on par with some versions of GPT-4 in the LM-SIS arena. And that is running at like speeds that are much faster than GPT 3.5. If you have something that's that intelligent that can run that fast, you can use it for like the first step of a multi-step process. Maybe you want it to like summarize something that then gets fed into a bigger model. I think that like workflow is like very useful. Maybe down like long-term into the future, this kind of like variable computation becomes part of a model. So it can use like less computation for very simple tasks and a little more computation for more complex tasks. But until we get there and that's actually baked in, like I think you can do that today with using different models.
Yeah, so I think like that day will come, right? So if you look at like our platform, there's like more than 100 models just like you can just use, right? So there's a one order of magnitude difference on the pricing. There's a one order magnitude difference on the speed and time to first token, right? So and also on the expertise on the quality side, right? So I think who knows what's going to happen when the whole thing converge, right? So but I think in the next couple of years, it probably be this like kind of the whole ecosystem get more kind of diverse. Both in performance, in pricing, and also in expertise, right? So yeah, so I think that's already happening today. Probably will be more and more like that in the next couple of years, in my opinion.
Well, we know we're at the early stages, and there's going to be an explosion of even more tools, more models, more tech, probably smaller models, probably more open source models. And there's lots of infrastructure opportunities, I think, in this space. So word to all the founders out there, this is obviously a space to watch. And I believe the stack is going to be a new stack. It's not going to look like the old ML ops stack. And so if you're building in this category, I think these are the folks to ask for advice. And hopefully you'll find good quality advice amongst your peers as well. So that's all the time we have. But thank you, guys. That was great.